name is dice Alejandra Gómez Mola. I am enrolled in a telecommunication engineering program in the electromagnetic course. In this video, I will explain how to calculate the magnetic flux toward a motor coil with entonces, how the flux varies with time, and how to determine the induced electromotive force using Faraday's law are results are obtained using the given values of alpha, beta, and gamma. 5. Magnetic flux through a single loop. The first step is to determine the geometry of the loop using the parameter provided. The radius is calculated from the expression dependent on alpha, beta, and gamma with the radius. The surface area of the loops and maintained using the standard circular area formula. Next, the magnetic field vector is valued by substituting the value and parameter in kernel expressions. Since the loop surface is oriented in k direction, only the k component in the magnetic field contributes to the flux. This allows computing to creating this represent the product between the magnetic field of area. The angle between the field and the area vector is gained, and with the information the magnetic flux from one loop is obtained using the causing base the formula. Cause. 2. Total flux for in terms. The number of turns is determined using the definition that depends on the parameters alpha and beta and theta. Once the value is count, the total flux of the motor coil is when we multiply the flux and single loops with numbers of turns. 3. Flux and function of time. In the next part of the program, the magnetic field becomes time-dependent through the angle. The angle is expressed as function of time using the angular frequency we calculate from gauge frequency. With this, the material flux becomes a constant function and the time. The flux is evaluated in three specific moments: t equals 0, t equals 10, and t equals 7 seconds, hours in seconds. Because each of 2, 3 correspond to the completion of a full number of seconds, the value constant return is 2 maxims, and therefore the flux instant 3 instants. D. This is times or D or D. Three conditions if signs. For times corresponding to the previous calculated angle. The problem also asks for the moment in time when the time depends full matches the value period obtained for the angle of 3,319.5. The fifth and the cosine expression is inversely al arco cosine. Aquí está el arco cosine. Arco cosine. Function and divide the angular frequency. This gives the exact instant where the flux reaches the same value on oscillation. 5. Inducing EMF using Faraday's Lenz's law. To determine the electromotive force and the time-dependent flux expression is difference. We apply Faraday's Lenz's law. The inducing EMF becomes a sine function with the amplitude depends on the number of protons, the magnetic field, the area, and the angular. Sine. The final expression, this, represents how the induced EMF oscillates over time. Involves shifts, induced current at a specific time. Finally, the problem asks for the induced current and define with parameters. The induced EFM is evaluated to stands. Stands equals 17s. Value in 17s. The result is equal 0 volts. Then, using the supply battery board and the resistance of the wire of laws is applied to determine electric current in the circuit. I is equal B over R. Ohm's law. The height, the final current value the flow through the motor core at these moments. Finally, the problem shows how magnetic flux depends on geometry, field orientation, and time, and how these variations have risk to induced electromagnetic force. It also demonstrates the connection between electromagnetic induction and basic circuit analysis through Ohm's law. Thank you.